mean standard deviation is just 0 and 1. So you wouldn't have to actually, you wouldn't have to specify it because it's going to assume it's 0, 1. So maybe I'll make a note here. No, specify. So it's just like the Pnorm function. Necessary, you have to specify the mean and standard deviation. And if you were then to calculate this with R, this is going to come out to be 1.28. And then it says calculate the z-score of a song that's 4 minutes long. So I'm not sure what my value came out when I calculated this, and I don't really finish the calculation, so let me just do that. So this should come out to be 1.76. So part B, you should get 1.76. In part A, we said this is 1.28. So for part C then, is this true or false? Or is it yes or no? Is a 4-minute long song in the top 10% of songs played? So remember, this 1.28 represents the number such that it is longer than 90% of all the songs. So because 1.76 is bigger than 1.28, you would say it is in the longest 10% of songs. So you would say yes. Okay, so that's question 7. We have 2 questions left, so that's it for the normal distribution now. I want you guys to look towards the t-distribution. So when we're working with the t-distribution, we're no longer given a mean and standard deviation. What we're given is the degrees of freedom. And we're no longer going to be using Qnorm and Pnorm, but instead we're going to be using PT and Qt. So instead of using Pnorm, we're using PT, and instead of using Qnorm, we're using Qt. Again, this is for the T distribution. Okay? So this problem says, suppose that a research article reported blah, blah, blah. Wait, I think this is actually still using a normal distribution. My bad. Yeah, so this question, you can sort of disregard this. We don't have any time, or else I would have done this. My bad. We're going to move on. So let me just share my R with you guys. So now we're working in the t-distribution, and I'm asking you, given that we have degrees of freedom 11, calculate the probability that t is bigger than 1.81. Or let's see t is less than 1.81. So The t-distribution follows the same rules as a normal distribution in the sense that you can just do pt of 1.81, but you have to specify degrees of freedom, and it's going to give you everything to the left of 1.81, which is what we want because we want t is less than 1.81. When you run this, you get a value of 0.95. And then if I ask you to calculate what about p of t bigger than or equal to 1.81, well, it would be almost the same thing, except now we're going to be doing 1 minus again. If you notice, if you add these two values, you're going to get back 1. So it's nearly identical to the normal distribution, except now we're not specifying mean and standard deviation, we're specifying degrees of freedom. But the PT function works the same way as the Pnorm function. And then if you want the quantile, instead of using your Qnorm, you're going to use Qt. So you want the 90th quantile with 11 degrees of freedom, you would write Qt of 0.9 with degrees of freedom equal to 11. And then that will return to you the 90th quantile for that specified degrees of freedom. Okay, so I didn't have any problems to do for the t-distribution, but all the techniques we learned for the normal distribution, you can apply the same logic to the t-distribution. And one thing I'll note, I know this is definitely written in the lecture slides, is that if you're not given the degrees of freedom, but you're given the number of observations, your degrees of freedom is always equal to n minus 1. So your number of observations minus 1. Okay, so that's the end of this tutorial. If you have any questions, I'll stick around for a bit longer, and hopefully I can answer them. Okay?